Hello, my name is Santiago Diazgranados. I am a musician and composer, and I am going to explain to you the functioning of my generative, evolutionary, and algorithmic composition Duendes, or in English, elves. It is an electronic composition that evolves through time by means of biological evolution mechanisms like natural selection. It is based on a pre-existing evolutionary simulator called biogenesis. Biogenesis was created by John Keralt Molina, and if you want to get more information about that program or download the program, you can do so at biogenesis.sourceforge.net. So with this intention in mind, I created using MaxMSP, a program that codifies the genetic information of the virtual organisms in the biogenesis world into synthesized electronic sound that evolves along with the organisms, which I refer to as elves. This composition was made for my bachelor thesis, along with a written work that explores from a theoretical and philosophical standpoint the parallels between music and biological evolution, as they both involve analogous types of self-organization on different levels. The program is quite complex, so I'll try to explain how it works as concisely as possible. But if at any time you feel as if I am dragging on, you are free to fast forward the video. That being said, let's begin with the explanation. This is the biogenesis world. Here we can see a couple of elves interacting in the black screen that is their habitat. Each elf possesses a genetic code that we can see in this window right here. The genes determine the shapes and colors of the elves. They also determine their behavior, as genes that code for different colors also code for distinct behaviors associated with those colors. Each gene codes for the length of a segment, the rotation angle of that segment from its axis, and the color of that segment. The number of genes in an elf's genetic code determines the number of segments of that elf. However, there is a value in the genetic code called symmetry that determines how many times that segment is repeated. There is also a Boolean called mirror that determines how these are aligned. In my composition, the number of genes is limited to 3, because if I allowed for more of them, then the data output would be too heavy for the computer's processor. Biogenesis was made using Java. Here we can see the package where all the classes of the program reside. I created this class outside the package called valoresbiogenesis.java, or in English, biogenesis values. This class imports the required data from specific biogenesis classes and outputs it to an object in MaxMSP. Here I send a string with the required values to Max, preceded by the ID or index number of the organism to which they belong. This is the Max patcher, the algorithmic composition itself. This object right here, mxj valores biogenesis, has the same name of the Java class that I just showed you in Eclipse. It implements that class, or put another way, that class extends to this object. This metro object triggers the mxj object every 200 milliseconds, so that a continuous stream of data is sent from biogenesis to Max. These are the outlets of the aforementioned class. These root objects right here organize the data so that it is sent to the correct synthesizer models of each specific elf. The index numbers of the elves are cycled so that a maximum of 9 elves can produce sound at any given time. Hence, these numbers in the object that go from 0 to 8. These objects right here are sub-patchers, that is, patchers within the main patcher. They contain the synthesizers that produce the additive synthesis idiosyncratic for each specific elf. Each one of these models represents a possible gene. They exist as latent subsystems to be activated by the presence of an appropriate gene. This root object at the top of the model sorts the information of the gene by color. This one sorts it by the number that represents the position of that gene in the genetic code. This system divides one by the number of genes in the organism, which is then divided by 1000 to create a small gain unit. The larger the number of genes, the smaller the size of that unit. This way, elves with more genes will not sound necessarily louder than elves with fewer genes, keeping things nice and proportional. Down here, the mass of the organism, which is not in the genetic code, as it is bound to fluctuate during the organism's lifespan, is made inversely proportional to the overall organism's frequency. The rationale for this is that bigger elves have bassier voices than smaller elves, whose voices are high-pitched and squeaky in turn. This resulting frequency, called bass frequency, is represented by this object right here. It determines an inaudible frequency value from which data regarding the angle of rotation on the gene expresses the actual pitch of the sound. The collection of these different angles of rotation form a glissando chord of sorts whose frequency fluctuates with the changing mass of the elf. Here, the information of that elf's current level of metabolic energy is made equivalent to its overall gain. In each gene subsystem, the aforementioned gain unit is multiplied by the length of the segment coded in that gene. Also, the aforementioned base frequency is multiplied by a number derived from the rotation angle of that segment, where it is scaled from -1 to 1, so that the frequency of that sound is 1 octave below the base frequency if the angle is 0, 1 octave above the base frequency if the angle is 360 degrees, the same as the base frequency if the angle is 180 degrees, and every proportional value in that continuum. These two values are given as input to this synthesizer object. In this case, the oscillator produces a modulated sine wave which is the timbre representative of cyan segments. Segments of other colors have different representative timbres, like plane sine waves for green segments, sawtooth waves for red segments, square waves for blue segments, or more complex variation like these threefold recursive frequency modulations on a sine wave for white segments. This system right here modulates the amplitude of the whole package based on the symmetry value in the genetic code. If the symmetry is of the type mirror, which is represented by a value of 1 rather than one of 0, then the LFO that modulates the amplitude of the package is higher than if it is not. This way, depending on the symmetry value and the type of symmetry, the idiosyncrasy of the elf is further defined by rhythmic iterations given by the LFO. This subpatcher right here facilitates a quadraphonic system. This generative composition is intended as a quadraphonic installation. The position of the organisms on the virtual habitat of the biogenesis world, given by a set of x and y coordinates, are extrapolated to this quadraphonic system so that the listener feels as if the elves are moving around her as she stands in the middle of the installation room. Since the genes determine not only the appearance of the elf but also its behavior, they are bound to evolve by pressures of natural selection. Red segments allow elves to predate on the energy of other elves. Blue segments serve as defense from these attacks. Green segments allow for photosynthesis. Yellow segments increase the number of offspring of an elf each time it reproduces. White segments allow elves to infect other elves with their genetic code, so that they give birth to their own intruding offspring the next time the host reproduces. Cyan segments make elves move faster across the map, and gray segments kill anything that touches them. Now, I hope you enjoyed the description of my music project. A sample of the system in action is included as the other video on the same folder. So that's all. Thank you for your attention.